Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adha bin Roslan with my friend Muhammad AQIL Aiman bin Abdul Manap, Muhammad Shahul Ikman bin Jasdiman, Muhammad Syafiq bin Muhammad Sharif, and Nurul Fatihah Akmal binti Muhammad Zain will present our assignment for BMMH 3573 refrigeration system design, which is water cooled chiller.
For introduction, water-cooled chiller is one of the varieties of chiller that remove heat to cool the water used in industrial, project or home structure and recycle the water into the operating cycle. Chillers move heat from one area that needs temperature regulation to another. Efficiency of water-cooled chiller increased as wet surfaces are more effective at transferring heat and also do compression work at wetter bubble temperature. High pressure gas enters the condenser and where it is cooled to a high pressure liquid by the cooling effect by ambient air on condenser water. And last, high pressure liquid flows the expansion valve that quantity of refrigerant enters the evaporator. For flowchart process, the compressor takes the low pressure vapor from the evaporator and compresses it into high pressure vapor. The pressurization raises the saturation temperature, allowing the vapor to be condensed at a higher temperature. The condenser, a heat transfer device, removes the heat added to the refrigerant in the evaporator and the heat of compression by transferring the heat to a medium which is lower in temperature such as water or air. The expansion valve performs two functions. It controls the flow of liquid refrigerant between the condenser and the evaporator while dropping the high pressure refrigerant to the lower pressure used in the evaporator. The evaporator, a heat transfer device, allows the low pressure liquid refrigerant to absorb heat from the indoor air, changing the refrigerant into a low pressure vapor.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq. So today I would like to explain about the type of chiller. There are three types of chiller, which is water centrifugal pump, water screw chiller and water reciprocating chiller. So first we go to the water centrifugal pump. Water centrifugal pump or centrifugal chiller use the vapor compression cycle to chill water. It is also discharge heat to collected from chiller water and heat from the compressor to water loop. Second is water screw chiller. Water cooled screw chiller is compressor that will vaporize at small gravity and lower temperature. Compressor also compress the cooling gas into high pressure and high temperature. Liquid convert chambers minimum vacuum fluid cooling. Next is water reciprocating chiller. Reciprocating compressor is known as a piston compressor and is used by moving gas or air at high pressure and can be stored for other different purpose. Reciprocating compressor main element is that there is one or more piston and cylinder that are moving within the compressor. Reciprocating compressor create a vacuum by moving the piston with downward movement and reducing the pressure in the cylinder. The refrigerant is being sucked to the cylinder when the piston on the downstroke and then close the suction inlet valve. The refrigerant is trapped and then compressed on the upstroke of the piston and is discharged by opening the discharge valve when the piston reaches the top surface of the cylinder. Next is water cooled chiller component. There are four main components, which is compressor, expansion valve, condenser and evaporator. First is compressor. The compressor creates the pressure to force refrigerant around the chiller unit to provide cooling process. Compressor located between condenser and evaporator. There are few types of compressor, which is screw, reciprocating, and centrifugal. So next is expansion valve. That function upstream of the evaporator can be found in expansion valve, reducing the pressure of refrigerant fluid, controlling the quantity of refrigerant that turn back from the condenser and evaporator. Superheat introduce the compressor that causes the valve to open and close. Next is condenser. Absorption heat from the refrigerant that cycle and chiller, achieved by directing cool air over the condenser pipe of air-cooled chiller. Heat exchanger takes heat from refrigerant vapor, then transfer to water. Last is evaporator. The aim of the evaporator, as one of the most important parts of a chiller, is to transfer cooling energy from cold refrigerant to water or other coolant.
Factor of safety water-cooled chiller. The thermostat, an important element of safety feature and as the primary safety feature in the industrial chiller. Change in temperature can be efficient by this device located within the refrigerant circuit. The flow safety sensor in the chiller's refrigerant unit has ability to identify potentially dangerous temperature condition and turn off the circulation of coolant in response to their detection. The chiller system also recommend a safety factor of between 50 until 100%, since it requires knowledge of the surface area for heat transfer as well as for characteristics of the material. It is the most difficult aspect to find. A safety device is a piece of equipment such as a fire extinguisher, safety belt, or burglar alarm that reduce the quantity of loss or damage that can be caused as a result of a fire, an accident, or a break-in. Common chillers feature reliable safety protection device such as overload current protectors, compressor motor overheat protectors, high and low pressures protectors, and exhaust overheat protectors.
Maintenance of water-cooled chiller. According to the climate and geography condition of our country, the normal usage time for water-cooled chiller is about 3,000 heat per year, or per year. For the sake of long-term reliable running of the unit and the increasing of lifespan as well as reducing of costs, it is important to maintain the unit. In order to increase the lifespan of the unit, we need to improve efficiency and save the energy. It is a must to inspect and maintain the unit periodically. Users should record the inspection and maintenance of each month, each quarter, and each year so that is convenient for the repair to handle the malfunction. Okay, as we can see, there are sample table that we can manage by weekly, monthly, and quarterly. So at weekly, we need to inspect the oil level of compressor. For monthly, we have three maintenance to do, which are inspect the water flow of inspect the water flow of the circulating system. Second, inspect the connection of wire and electric insulation. And last, inspect and adjust setting temperature. For quarterly, also we have 3 types inspect, which are inspect refrigerant capacity, inspect device for drying and filtering, and last, inspect the pressure and power supply. Daily operating of the unit. The unit comes with 2 modes, which is runs with manual or automatic for the daily and stop of the unit. Okay. For automatic, the automatic operation is based on controller that automatically start and stop of the unit. For manual, we have button on off on the controller is used for manual start and stop of the unit. The emergency stop button on the door of the electric control cabinet is used for the emergency stop of the unit during maintenance and also debugging.
Maintenance of the main part. First, keep an eye on the system suction and exhaust pressure while it is operating. Determine the cause of any anomalies and fix them if any exist. Second, do not casually adjust the set point of the control and protection parts. Third, check if the wire is loose. Fix it if it loose. And lastly is check the reliability of the electric parts periodically and replace the invalid or unreliable parts.
Assalamualaikum and good evening. My name is Muhammad Shahrul Iqman bin Jastiman. So today I will be explain about our drawing or assembly view of device. First of all is water cooled chiller. As you can see at the top of the chiller, it has a compressor. The left side is condenser and the right side is evaporator. Next is assembly view of cooling tower. The cooling tower at the top, it has a motor or blades of fan, and actually in our SolidWorks it has a fin at the side of cooling tower, but our laptop cannot capture the fins. Third is assembly view of air handling unit. In the air handling unit, it has a motor, it has a bearing, and also it has a we call the X coil. And the main function for this design is to have a nice air ventilation. Okay, so is function of the water cooled chiller. First, the function of water cooled chiller is provide cooling by absorb heat from the building spaces. Next, chiller remove the heat from water by using refrigerant cycle. And the third is chiller work by removing heat from cooled water in the evaporator. Fourth, the compressor drive the entire process. And lastly, inside the condenser, the heat is transferred to the condenser water or directly to cooling tower. Okay, our second device is cooling tower, which is the cooling tower. The main purposes is to cool the water and as a heat exchanger. It also receives warm water from chiller that is now as condenser water because it get heat in the condenser in the chiller. The roles of cooling tower is cooling down the water so that water can return to chiller to collect more heat. Next, the cooling tower remove all the heat by using water to transfer process of heat waste to the atmosphere by through the all the fins at cooling tower. Next is cooling tower operates by evaporating a small amount of water then recirculate it throughout the unit. And lastly, cooling tower warm water is mixed with the cooler air then release a latent heat of vaporization that cause the water to cool down. And lastly is the function of air handling unit. Air handling unit distribute are around the defined area of the building, which is ASU use ductwork as a connection which provide route for air to travel around the building and supply to the confined space. ASU use fan to suck in ambient fresh air from the outside, then remove the dust and dirt from the air by filtering it. The filters of ASU have so many types, and the cheapest one and the most efficient is wool. Next is the air will push out around the building after it pass over those coils. And another ductwork are collecting warm air from the building and bring back to ASU through another fan. And lastly, a handling unit will use fan to eject air from the building and ASU.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adha and I am going to explain the discussion on how the device works. Chiller works by supplying the refrigerant at required temperature to the evaporator. The fluid is then pumped through the process by the chiller to remove the heat from chiller and direct it back to the return side. There are 4 cycle stages of chiller. For stage 1, when water from manufacturing process goes into the evaporator before going into the chiller cycle, the heat absorbed by the refrigerant during this phase and manifests itself initially as a liquid to gas phase change. The atmosphere that made contact get cool as the heat from water is absorbed by the refrigerant and causing the water leave at lower temperature. The cool air is distributed to the required area. For stage 2, the gas refrigerant then enter the compressor after transitioning from the pre-liquid stage into the gas phase. The temperature and pressure of the gas rise as is condensed in the compressor, allowing for high pressure entry into the following stage. This rise in pressure and temperature as it leaves the compressor is crucial because the refrigerant needs to transport enough heat to the condenser in order to release heat from inside the condenser. In order to maintain a high enough pressure inside the evaporator to once again absorb the heat, the compressor must suck refrigerant into the evaporator at the proper moment. For stage 3 is the condenser. The gas with a high temperature enters the condenser. The gas refrigerant is changed into a saturated high-pressure liquid in the condenser. Water enters the cooling tower after the water temperature rises because the condenser is present in a different cycle between the cooling tower. Because the primary function of cooling tower in water-cooled chiller is to cool the water that is used, and because the condenser uses this water as its main energy sources. This is the point at which the water undesired heat dissipates and the temperature is returned to the desired low level. The condenser undergoes the previous indicated heating procedure to release the gas refrigerant from the heat sources that is now being talked about and must be removed by the cooling tower. By coming into contact with the airflow as it passes from the condenser to the chiller cooling tower, the water is able to heat the air before returning to the condenser. For the last stage, which is stage 4, the refrigerant just has to go through the expansion valve at the end. Expansion valve diminish and expand the refrigerant. The refrigerant in the expansion valve undergoes this process, which results in a mixture of liquid and gas. Eventually, the same substance returns to the evaporator to restart the cycle, this time with hot water entering from a different angle.
In conclusion, water-cooled chiller is the heat that has been removed from the processed water by a chiller is sent through a heat exchange with the surrounding atmosphere. Next, when we compare to air-cooled models, the efficiency with which the condenser is cooled by the heat exchanger is significantly higher. Okay, also water chillers can cool the water to a temperature at the lower than the surrounding environment and create the powers of the refrigerant cycle in combination with a mechanical compressor. For utilizing a chiller to recirculate the cooling water, remove that need for an inefficient single pass through the system. And last, the water is cooled to a temperature of 40 degrees by the system. And once it reaches that temperature, it is recirculated through the air handle of the water coil. That's all. Thank you.